Welcome everyone. Today we'll go over high-level architecture overview of Acumatica platform, which makes it easier. Will make it easier to understand all the pieces of the puzzle here. We'll go through platform architecture, moving on to the essentials, and then we'll briefly look at some of the additions that were done as part of the platform. We'll talk about Acuminator. We also have a session later on today. So those who are interested in that can join that session to gain more information about it. We'll also look at reusable business logic, webhooks, etc. I will also include some of the resources at the end of the session where you will find it very useful and help you to dwell deeper to learn more about the Acumatica framework programming. Uh, this session is geared towards developers who are just starting to learn Acumatica platform or searching for answers to complete their puzzle. Will be quick. It will be a quick revision for those who are seasoned developers and are already using the platform. So let's dive in. First, we'll talk about the platform architecture. The XRP platform was born in the cloud. Creators wanted it to be expandable, future-proof, and reusable solution. As you heard early talking about this, making it modern. So that was the motto from the get-go. It was specifically created for the cloud. Also, the design philosophy was that when we build product using the platform, it would last longer, stay current, and provide incremental benefits for many years to come. Acumatica ERP is one such example, and many other ISV solutions is also an example of this application that's built using the XRP platform. You can see here on this slide, the technology block is separated from business logic through the platform. So platform is a set of tools and building blocks that are used by developers to build cloud-ready business line of applications from ground up. These tools and building blocks are part of framework and are available to you so you can get same benefit of using platform-based product. You can think of Acumatica XRP platform as a RAD tool or the rapid application development tool. It's an engine which powers your solution. You focus on building state-of-the-art business applications without worrying about how to make it work safely and securely in the cloud, without having to master or become proficient in various technologies in order to program for the cloud. You focus and spend time building your applications, business logic, and not learning a new technology or programming language. So that's the benefit that you get by using the XRP platform and building your applications using this platform. So let's look at the building blocks of the architecture here. So first we have the runtime engine that's based on the .NET. You heard early talking about we are moving on to including the core .NET Core and all that stuff that we'll see in short period of time in future. Then on top of this runtime environment, the development environment that we use is the Microsoft Visual Studio. So that's our application development tool. That's the IDE environment that we use. And then we have built these different blocks, reusable blocks, and provided as part of the framework. We call it as part of, we have classified that as part of the system foundation layer that you see here. And using these blocks, we have abstracted and built some more business application related building blocks. We call it as application layer. Rather, we call them as tools that you use to build your application. So at the top, you see that the ERP, Acumatica ERP, is built using these XRP platform tools and framework components, which allows you to create applications, business line of applications, which are ready for the cloud. Let's look at this in slightly in a different angle. As you can see from this diagram, it's a classic 6-tier web application architecture. We have a client over here, the client layer, which can be accessed using the browser or a mobile device, or third-party applications using the Acumatica API. The client connect or works with the HTTP secure protocol with web server hosted using Microsoft Internet Information Server. And as part of the platform tools and components, this is broken down into, we call that as an application server or application layer, which runs on the Windows based machine. This application layer consists of the 3 components, the blue ones that you see here: the presentation layer, the business layer, and the data access layer. The presentation layer, as it indicates, the name suggests, it shows you the information, it works and communicates using the controls, etc. The actual core logic or the business logic is residing here as part of the entity business logic controller, or simply we call it business logic layer. And then the final one is where actually your data is manipulated, or where it helps you to do the CRUD operations. So that's your data access layer. And finally, we have the database server. That's where all the data is persisted. We also, the way how the framework is designed, it kind of helps you to work with different databases. So what we call it as a database agnostic system. So all this programming that you do here as part of the application layer, it can readily work with other different databases. Currently, we support MS SQL, MySQL, the AWS Aurora ones, and so on. Let's get a little deeper here and talk about these 3 blue boxes that we have. These are the essential components. So the first one is the presentation layer. Here's where user interface communicates with the core of Acumatica. It could be using the web form. We use ASP.NET for that. Or it could be third party communicating through the web services. And moving forward, the focus is more on the REST APIs. The middle layer is where all the business logic sits in, and this is the main component that handles the business logic. It consists of 2 parts: the entity model, where the data is connected, they are referenced between each other using tables, their primary and foreign keys, etc. And the second part is the entity business logic, where it's comprised of code that invokes actions and events. These actions and events can be triggered when the user is doing something on the web form or in the UI. You can program these actions and events to implement the required business logic. For example, you can do some validations upon user entering some data into the control and so on. And then the third layer is the the DAL, the data access layer, which implements the ORM, the object relational mapping that happens as part of this layer by using the business query language. And we'll see some of those things in a moment. It works with two different components, as you see here, as with the session, which stores the modified data or the cached data. It's a temporary storage of data, and data is modified by the user but not yet saved in the database. And then the other one is the database management server component. That's where the actual persisting happens. Okay, so next, let's talk about the platform essentials. So we'll go through all these at a very high level, which will give you an idea as to what all these things are and what they mean. So let's talk about the data access class, or simply we call it as DAC. As you can see here, we have on the left side the table, SQL table, called as product, and it contains some fields and so on. And see how it is mapped using the class in Acumatica framework. So there is a public class derived from an interface called as IBQL table. So the framework understands that, hey, yes, this is a product table. And then each fields are kind of declared as a property and as abstract class definition, which is used as part of the BQL to work with that particular field. Now here, as you can see, that every DAC is mapped to a table. As you can see here, the public class product. It has various fields. These are mapped as properties and has the abstract classes that is used to make queries in the system when you are working with that. And every field can have set of defining properties. It defines what the data type of that field is and what are the other characteristics of that field. So field can have additional information through what we call it as attributes. It's a declarative style programming where you can specify various other information about that particular field, like key field, whether it's a key field, whether it has a default value, what's the caption or the display name, and so on. So here are some of the examples, what each one of those things do. So each attribute has some meaning. It reflects functionality and the visual presentation. So it kind of dictates the business logic as well as the visual representation of the field. So like if you see here, if you use a PXDB string, then it simply renders it as a text control. But if you use PXBool, then the system, the framework understands that, hey, this is a yes or no kind of a value, and it's rendered as a checkbox, and so on. If it's a date field, then it will be a date control, all that kind of thing. Here is a simple example. You can see how the document date field, so doc date field in the AR register table is rendered on the Acumatica screen. So it kind of shows it up as a date control with a display name of date, and it's defaulting the value. So we are using an attribute to default the business system date into that control. So that's how this whole thing comes together. Next, let's look at the business logic controller, or we call it simply as a graph. So a business logic controller is a class that serves as a controller for the screen. It defines the data and business rules for the screen. It also defines it defines data using what we call data view members. So you see that here the example of this is products is a data view member, which is nothing but like declaring a data selection or the data manipulation statement. In a very simple terms, we can say it's like select bunch of fields from table product. It implements various business rules. So the business logic controller implements various business rules, validations, and functionality by defining relations between various data entities. An example would be, another example would be, is the sales order business logic container. It will contain various entities like order header, order detail line, customer information, billing and shipping addresses, and so on. And these entities are related to each other to provide the overall sales order functionality. Let's dwell deeper, slightly deeper into the data views. Data views are graph members that are used to perform the CRUD operations, so create, read, update, delete operations, using the data access class. View has two components, as you can see here. It kind of uses the PX cache object that will hold the data records that are modified but not yet saved to the database, so that it holds into the application layer. And then the view, PX view, is the component that is responsible for retrieving data from the database and placing it into the cache object. It knows what kind of statement that it needs to generate, whether a data select statement, update, delete, and so on. And it also kind of helps in caching the data within the application layer, which helps improving the performance. So here's a diagram that shows how all these pieces come together. So we have a graph, or the business logic controller called as journal entry, which declares two different views. One is the batch module and the other one is the GLtron. And you can see that how appropriate DAC objects will look like, and in the database how it drives these two tables. Next, let's move on to the BQL, what we call it as a business query language. This is the engine that is responsible for working with the data. You can see here a data view is PX select, some table where some conditions. This gets translated into a BQL query, or a business query language query, and gets translated underneath by the engine, by the BQL engine, to appropriate transact SQL statement. So BQL is compile time query engine that translates to transact SQL at runtime. This allows for compile time syntax checks. It builds abstraction layer between transact SQL and the application, and that's where the database agnostic nature of the system, of the framework, comes into play. It allows application to be, work with different database backends. Earlier I mentioned that we have support for MS SQL, MySQL, AWS Aurora systems, and so on. So you see this simple BQL statement, public select product, where the view name is called as products, results into, it gets translated into a transact SQL where it says select bunch of fields, and the list of fields depends on the fields that you have defined in the data access class. You can also control it to limit the field selections by using some other constructs that are available in the system. Here you can see that it automatically adds the order by clause, uh, which the BQL adds it. It's always based on key fields first, and then if you have specified some more ordering, then those fields are added as part of the converted SQL. Here is a little bit complex BQL where you can see that multiple tables are involved. So we have supplier product table joining to a supplier table based on some join conditions, and there are some record selection criterias and all those kind of things. This is the classic way of defining the BQL. You can see that there are a lot of brackets and parentheses. Since Acumatica application source code is open to you, you can actually view the ERP source code. You must have come across some of these kind of things while wading through that code. So let's move on to the next type of the BQL query. What we call it as a next generation of BQL. We call it as a fluent BQL. You see that this one is much easier to read. You can see that there are not that many those pesky nested brackets and so on. And the syntax is based, syntax is very easy to read and write and follow. And it's somewhat similar to the LINQ queries. Mark earlier alluded us to his blog post where this post kind of talks and explains and provides a good insight into how these Fluent BQL queries kind of stack up against the classic original BQL ones. You can pass parameters to select the required information from the database using this BQL. So you can see that here I'm using the where clause to specify the conditions, and I'm using this required construct to say, hey, required, and you pass the parameter to that. So I am passing the value true to that. So where product is active equal to true. The same kind of things that you see here, instead of passing the parameter, you can pull that information from the context, from the given context of the various different data views that might be available within your business controller class. The BQL also supports both the BQL and the Fluent BQL supports the LINQ semantics. So you just add the LINQ namespace to your project or your code, and then you can write BQLs using the LINQ syntax as well. As you can see that sometimes these things can be a little bit overwhelming when especially working with BQL initially. And also sometimes, it becomes difficult to spot things when you have very large complex BQL queries. So we have this tool, which is part of the platform called Acuminator, which makes the life easier for developers. It's a Visual Studio extension. It does a lot of validations, helping developers to avoid common pitfalls and mistakes. It also formats the code, as you can see here on the slide. It makes it easy for readability, etc. We highly recommend this tool for all the developers. There's a session coming up today, later on, by Sergey, where he'll be talking in detail about this tool. Let's move on and talk about the user interface aspect of the framework. For now, we are still using the ASP.NET, so we'll look at that. You can see that here is a typical example or the view where the screen, the form, the ASP.NET form is shown. Everything is ASPX custom controls. You can see that all of them starting with PX, all this. And these controls kind of implements specific functionality. These are all server-side controls that helps to define consistent look and feel, design and behavior of the screens. We talked about attributes that define the functionality of individual fields within the tables. So here, this slide kind of shows you how each of these attributes kind of translates to an appropriate control. The next one is, like when we are working with these Acumatica screens, let's say we are entering some information into these screens, into those controls, and we want to take some action by notifying the server, because all these things is happening on the client side. So we can issue or we can perform the post back to the server so that server can take some action. And for that, these controls have this property called as commit changes, which then helps you to do that. An example would be like when you want to validate the data that is entered by the user into the control. So let's say in the text box control. So when value is entered and the user tabs out of that control, this property, if it's set to true, it will send the notification or the post back to the server, and your server-side code then can validate that entered value. Next, we'll talk about event model that's available in Acumatica framework. These events are generated within the system as and when user is working with the screens. So the client generates the call. You can see that here, the client, the web browser, or the mobile, or the third-party application, which is using Acumatica API to communicate with Acumatica. So it generates the call to server. The ASP.NET custom controls comes into play. They handle this call. They pass this on to the business logic controller, and in turn, this controller determines and decides using the data views that are declared in it, and raises different events and actions. So the cache here performs the required CRUD operations by raising the appropriate sequence of events. Each operation raises specific event sequence, which you can utilize to program your business logic or to program your functionality that you need. Let's see this in a slightly different light here. This is a much more concrete example where you can see that you have a data entry screen here, and then your page, and the business controller, a business logic controller that kind of executes and calls all different events, the sequence of events. Events are declared. Here is the example, or it shows how you can declare all these events. You can have like the DAC name underscore field name underscore the type of event that you are declaring. And it takes in couple parameters, the cache that it's working with, that is associated with that view and that DAC. and the arguments or the event args that comes through that. So it will contain, in case of this field updated event, it will contain the newly updated value of that particular field. You also can use a slightly different semantic that's generic. It's declared pretty much similar, but you can see that you specify the DAC and the field and those kind of things slightly differently. The advantage is that you can easily locate all the references for these kind of events, because here it becomes difficult, but this one becomes much more easier. You can easily locate all the references uh, for those events. And events can be implemented as part of those attributes. We talked about it earlier, where you define the characteristics of your fields using different attributes. So these fields can have some events defined within themselves. You can see that here, field updated event or row inserting events. These events are defined as part of this awesome attribute, which then can get triggered at appropriate time using the by your business logic controller. So let's understand this event model. We have like 12 row level events and 5 field level events, and then there are so many other things in between. But suffice to say that we have all kind of events that lets you build the kind of logic that you want for your application and drive the functionality that you need. So this diagram kind of shows that there's the field level events that gets triggered first, and depending upon what kind of CRUD operation that you are doing, those events will be triggered. And then you have row level that gets triggered next in that particular order. We strongly recommend to understand these model to make programming easier with Acumatica. And all these things are documented in various sources that are available, and we'll see them towards the end of this session here. Here are some commonly used events. You can see that you have pair of events, row inserting and row inserted. So just before the row is being inserted, you want to check the values, then you can implement your row inserting event. Or you want to do some field validations, then you can see that we have here field verifying event. So these kind of things, these kind of events you can program to implement the logic that you need. Okay, next, let's move on to the customization capabilities of the platform. We have seen now that what the platform is, the essential components of those platforms, and including the other tools that are available as part of that. Now, how power user or end user can customize these kind of applications. To customize the application which is built using XRP platform, we have what we call it as extensibility framework. So let's look at what all we can customize using this extensibility framework. You can customize user interface using the tools that are provided. We have customization project editor, or using Visual Studio, you can arrange the controls. Mainly, you use the tool that is available to you to modify the existing screens. You can modify the business logic of the given screen. I alluded earlier, I mentioned earlier that Acumatica comes with the ERP source code, which is useful to understand how a given screen functionality is implemented, and then come up with a way, best way to modify or customize that functionality to your needs. So you can customize the business logic. You can pretty much customize all the things that are there as part of that, and so on. And also you can create your own custom tables. You can add custom columns or fields to an existing ERP tables and so on. So here is a diagram that kind of shows where exactly this extension framework kind of fits in. So you have a XRP framework using which you build your ERP application or any application you built using XRP framework. And that application then can be customized using the extensibility framework. And you can customize the business logic container, the data access class, attributes, and all that kind of things. The custom tables you can add, so on. So here is the example of how that looks. So if you want to extend the table, then you are going to use the DAC extension. It's called PXCAS extension. If you want to extend or customize your business logic controller, then you are going to use PX graph extension for that. And how all these things comes together, you see here, you create your customizations, and that results in the runtime fusion of all these customized code that you have. So the customization kind of layers on top of the base system. So you don't override or you don't lose the base functionality that's available there. Next, we'll talk about some of the things that were added as part of the framework. The concept of reusable business objects. This is a modern approach in Acumatica framework. It allows you to reuse the same business logic for multiple business logic controllers or the graphs. It's useful specifically for extensions and customizations. The frequent scenario to have same extended business logic for different existing Acumatica screens. You can see that some of the examples here listed. It's like the discount functionality, the multiple currency, and so on. This functionality is implemented as abstract classes. And basically what you do is use these abstract classes and declare your own actual objects using these abstract classes within your BLCs and wherever that you want to use it. The next one talks about the ability to access protected members of the base graph, of the base business logic controller in your customizations. So here you can see that there is an graph extension. That means we have extended the sales order entry business logic controller. And in that, we want to use this set read only method, which is protected, which is declared protected in the base graph or the base business logic controller. In order to access that, we can use this PX protected access property, or it's not property, sorry, attribute. This is the example that shows, and then you can basically call it within your graph extension. We also added part of the framework, the webhooks. So now you have this interface, iWebhook handler, where you can have Acumatica as a listener system, so that third-party applications can call out to this webhook and interact with the Acumatica application. Okay, so that kind of brings us to the end here. What next? What next steps one should take to dwell deeper into Acumatica framework and become a seasoned Acumatica developer? So these are the resources that are available at your disposal. So we have a big community that you can go where lot of knowledge base articles, and you can ask questions and get answers to, and so on. We have Open University and Partner University that has various courses available that you can go through at your own pace. We also have online documentation place or the site. GitHub that Mark mentioned earlier. We also have Stack Overflow channels where you can go and ask questions and get answers to. So these are some of the resources here. And that's it for me.
Thank you, Nyan.